we need to finish the review for chapter 20. What question are we on? 6? All right, so this is on page 372. We did 6, we're on 7. Oh, no, we didn't. No, we didn't do 6. Okay. Number 6. I sprung an air leak. All right, number 6. The Census Bureau is planning to take a sample amounting to 0.1% of the population in each state in order to estimate the percentage of the population in each state earning over $100,000 a year. Other things being equal, the accuracy to be expected in California is about the same as the accuracy to be expected in Nevada. False. Why? Accuracy depends on what? Sample size. Is the California sample going to be larger than the Nevada sample? Yes, because it's a percentage, right? We're going to take 0.001 of California, which has 35 million people, versus 0.001 of Nevada. So because the number taken is a ratio of the entire population, it matters because the sample sizes will be different. Now, if it said 2,000 from each state, then they'd be the same. But because California is larger, you're going to sample more people. 2, the accuracy... Oh, California is expected to be much higher than Nevada because they're like 17.5 million, or 17 times more people in California. Okay, number 7. 500 draws are made at random from the box. 60,000 zeros, 20,000 ones. True or false? The expected value for the percentage of ones among the draws is exactly 25%. So it would be 20,000 divided by the total number, which is 80,000. Oops. 0.25. True. Okay, which means we can change our box. What would we create for our box? 0.25 ones and 0.75 zeros. Okay, the expected value for the percentage of ones among the draws is around 25%, give or take 2%. Well, we need to calculate this. So my box is 0.25 ones and 0.75 zeros. So the EV is definitely 25%, so that's right. The SD is going to be the square root of 0.25 times 0.75. So the square root of 0.25 times 0.75. Now, do we want the SEN? No. We want the SEP, so we can do the shortcut. So I'm going to take 0.433 and divide it by the square root of 500. What's the long way to do that? It's SD times root of D over D. But that simplifies into 0.433 divided by root 500. So divide that by the square root of 500. And I get... True or false? True. 0.19. That's pretty close to 0.2. Okay. So the percentage of ones among the draws will be around 25%, give or take 2% or so. Oh, sorry. B is actually false because the expected value is a number, not a percentage. So B is false, but C is true. I don't know. I don't know. All right, D. The percentage of ones among the draws will be exactly 25%. If we do 500 draws, will we get exactly 25% ones? No. Chance error. The percentage of ones in the box is exactly 25%. That is true. And the percentage of one in the box is around 25%, give or take 2% or so. No, we know the population, and it's exactly 25%. All right, 8. In a certain town, there are 30,000 registered voters, of whom 12,000 are Democrats. A survey organization is about to take a simple random sample of 1,000 registered voters. There is about a 50-50 chance that the percentage of Democrats in the sample will be bigger than... All right, so let's look at the population. The population contains 30,000 people, right? And 12,000 of them are Democrats, which is 40%. So we can get rid of this, and our box would be 0.4 ones and 0.6 zeros. Okay? If I make 1,000 draws, what do I expect? I would expect in 1,000 draws to get 400 Democrats. Okay, so the question says, there is a 50-50 chance that the percentage of Democrats in the sample will be bigger than blank. 400, because that's the EV, right? If I were to draw this, my EV is 400. How much area is to the right? 50%. Okay, so that question was just trying to figure out if you understood the, I almost said nomenclature. You don't even know what that means. The language. Lingo. Yeah, there we go. So half of the area is to the right of the EV, and half of the area is to the left of the EV. Okay. 9. Yeah, bigger than 400. Or 40%. Nope, because it says, oh, percentage. In the sum, yeah, I guess either 400 or 40% would both work. 9. 600 draws will be made at random with replacement from the box 001. The number of ones among the draws will be around blank, give or take blank or so. Oh, what? So, my box has 2 zeros and 1 1. So my percentage is 0.33, right? 1 out of 3 times you'll get a 1. My SD is going to be the square root of 1/3 times 2/3. So the square root of 1/3 times 2/3 is 0.47. Do we need the SEN? Nope. We want to skip straight to the SEP. So we're going to do 0.47 divided by the square root of 600. Now once again, the other way to do it is like this, which is exactly the same thing. Okay, so I take 0.47 and I divide it by the square root of 600. Oh, maybe. And I get 1.9%. So the answer is the number of ones among the draws will be around 1/3 or 33%, give or take 1.9%. Or if you did it in a number form, it would be 200 plus or minus 0.4714 times the square root of 600, 11.5. Right. So this is the EV and the SEN. This is the percentage So those mean exactly the same thing. All right, a coin is tossed 2,000 times. Someone wishes to compute the SE for the number of heads among the tosses as the square root of 200 times 0.5 is about 22. Is this the right SE? So the SE should be calculated using the SD times the square root of the number of draws. What is the SE of a 1-0 box? 0.5, therefore, it is right. Yep. Yeah, they wrote it. We usually write it the other way. 11. A university has 25,000 students, 17,000 are undergraduates. The housing office takes a simple random sample of 500 students. 357 out of the 500 are undergraduates. Fill in the blanks. For the number of undergraduates in the sample, the observed value is... So in the number in the sample that we observed is 357. That's how many we saw. How many do we expect? So 17 divided by 25 tells me that... Nope. Helps if you push the right button. What does that mean? 68% of the students are undergraduates. How many are in our sample? So we're going to multiply that by 500. Yes. No, sorry. So we expect, the observed was 357. The expected is 340. So we were high. 340 is 500 times 68%. So the number we got was higher than expected, right? Okay. For the percentage of undergraduates in the sample, the observed value is... What is our observed percentage? No, the 68% is the expected percentage. That will be the observed percentage. So 357 divided by 500. I expected 68%, and I got 71%. Can that happen? Yeah, chance error. Or... So I expected to get... So I observed 71.4, but I expected 68. 12. There are 50,000 households in a certain city. Isn't it nice? All these cities have a really good number of people in there. The average number of persons aged 16 and over living in each household is known to be 2.38, and the SD is 1.87. A survey organization plans to take a simple random sample of 400 households and interview all persons aged 16 and over living in the sample households. The total number of interviews will be blank, give or take blank or so. Okay, so we have 50,000 in the house, and each house has on average 2.38 people 16 and over with an SD of 1.87. And they're going to take a sample of 400 households and interview all people who are 16 and over. The total number of interviews will be around... They're going to go to 400 houses. Right, and each house contains 2.83 people that are 16 and over. So 2.83 times 400... 38. Oh, sorry. 2.38 times 400. So they plan to talk to 952 people. Give or take what? Times times the square root of 400, right? Because the standard error of number is going to be the SD times the square root of 400. So 1.87 times 20. Give or take 37.4.